Oil and gas producers use triethylene glycol, often abbreviated TEG, to dehydrate natural gas. When gas comes into contact with TEG, the water vapors entrained in the gas are absorbed by the TEG. The glycol essentially soaks up the water. This purifies the natural gas so that the producer can sell it. The most common issue that plagues dehydration systems is glycol contamination. The importance of glycol filtration in a dehydration system cannot be overstated. The efficiency and longevity of the producer's glycol pump depends on the particulates and contamination being removed from the glycol. In this video, we're going to show you how 3 of the most common glycol filters work. Producers use filters to remove impurities from the glycol. Proper maintenance is key for any filter or strainer to operate for an extended period of time and the overall health of the dehydration system. The 3 most common glycol filters include strainers, sock filters, and carbon filters. Let's look at each one in detail. Strainers are steel housings with stainless steel mesh screens. Strainers catch larger particles in the glycol flow line that can easily damage the glycol pump. Strainers can be installed both upstream and downstream of the glycol pump, but most commonly the strainer is placed on the low pressure side from the surge tank to the pump. Strainers can restrict the flow of glycol when they become clogged with debris, so operators need to check and clean the strainers regularly to avoid starving the pump of glycol. There are 2 common types of strainers, T strainers and Y strainers. Different mesh ratings are available, but these are the most common: 16, 30, 50, 80, and 100. The higher the mesh number, the smaller the particles it can catch. The mesh number for strainers is usually denominated by millimeters or microns, but can also be assigned a mesh number, which is the number of holes per inch. Glycol sock filters remove gritty solids from the glycol flow stream. They are most commonly installed just downstream of the flash separator. If the filters are located on the high suction or high discharge side of the glycol pump, one danger is that the sock filters can disintegrate due to extreme differential pressure when it becomes plugged or clogged with debris. Sock filters located on the low pressure suction side of the pump can also starve the pump if they become plugged. Sock filters are made of 3 layers of materials: the core wrap, filter media, and the outer sock. It may be necessary to start with a larger micron rating and progress to a smaller micron rating as the glycol is cleaned of contaminants. The most common size for glycol is 5 microns. Producers install carbon filters downstream of other strainers or filters. Carbon or charcoal filters remove liquid hydrocarbons, compressor oils, degradation compounds, and other carbon impurities from the glycol flow stream by catching these molecules in the charcoal's pores. Some of these contaminants can cause the glycol to foam, which can create issues in the dehydration equipment. The carbon filter absorbs hydrocarbon impurities from the glycol until it becomes saturated, at which point the filter needs to be replaced because it cannot absorb any more and the hydrocarbons will pass through it. There are many different contaminant sizes in a typical dehydration system, and if the pore size of the carbon is too small, larger contaminants can clog them and decrease the effectiveness of the filter. With these carbon filters collecting impurities, glycol foaming, excess buildup in vessels, and water content can all be lowered. All 3 of these filter types can be used on the same location, and depending on the filtration needs, several of each type may be installed. To speak with an expert about your glycol filtration, contact your local Chemray store or authorized distributor.